Hi, friends. Welcome again to another episode of Beyond the Clouds Edge to Edge Transformation. As I've said earlier, this is also for me an opportunity to reconnect with some of the most amazing people I've met and worked with in my career. And one of them is Margaret Schmitt. Margaret, we worked together briefly for about a year or two, but we've been following each other's careers. And you've done some really amazing things since Sun Microsystems. Tell us a little bit about yourself to our audience. Go ahead.
Shankar, it's wonderful to have this opportunity and to collaborate with you again. It's always inspirational to follow the work and follow the topics and initiatives that you're driving. As you can see, since our time together at Sun Microsystems, I've had the opportunity to work with some amazing teams at ANSYS, at Apache Design Solutions, at CG Tech, and inside of Sandvik to bring amazing technology to our customers, to the industry, and help solve some of the very complex challenges in semiconductor design, in manufacture, and really push the boundaries of what innovation can be, thanks to engineering simulation. So it's been an amazing, astonishing, and humbling journey to work with so many individuals along the way.
So, this is great, Margaret. You have worked in so many different spaces. I remember there was a time when you worked on power and power optimization, manufacturing. Can you give us an idea of how your career has progressed through all these things? And what do you see? I mean, technology is moving at a breakneck speed right now. Where do you see it going?
I tell you, Shankar, it's been an amazing journey, hasn't it?
Yeah.
You and I have seen this firsthand in semiconductors. First, the mobile revolution, and then of course the autonomous revolution with driving, and autonomous driving, just to name a few, intelligent systems, and now of course, Shankar, we're seeing it. You and I have spent more than 25 years in technology, in semiconductors and software. And over the past 10 years, we've now seen this quantum leap forward and tremendous development with artificial intelligence, with AI. And to tie that in with semiconductors, how has that been possible? Well, it's been driven largely by two trends. And semiconductors and hardware, of course, is first and foremost a key enabler here. Hardware has finally become powerful enough to run these large artificial intelligence and machine learning applications, which of course are essential to generate truly impactful results. And of course, the second key enabler there is the availability of training material. Just training material has become plentiful and easily available through the internet. Great example, the data available on the internet in the form of pictures, photos, videos, written and spoken language. These are all an endless source of training material for machine learning. And as a result, of course, we've seen several breakthrough applications in artificial intelligence, and these are catching public attention, like ChatGPT, for example. And I'm excited about the many applications for artificial intelligence to come in our area, Shankar, in semiconductor design, in manufacturing, in building construction, where we have a tremendous opportunity to accelerate and lead the next wave of innovation.
And all these things that are happening at almost simultaneously, whether it's the acceleration and speed of connectivity, the hardware that's focused to specific applications, generative AI, all these things. How is it going to change people's lives, both as consumers or as people who have jobs? And where do you see it going? Personal life as well as professional life.
Shankar, you touched on an important element there, jobs. This is this is a resounding challenge in all of the industries we just mentioned. We talked about semiconductors, semiconductor design. We talked about the mobile revolution, realizing these autonomous systems. We talked about manufacturing. We talked about building construction. In all of these, one of the main challenges we're seeing today is, of course, the need for skilled talent, whether it's semiconductor production or it's machining. Look at the headlines today, and this has been reverberating over the last several years. I mean, let's just double it down and look at manufacturing. There is a study that I've followed for some time. It's a study from 2021 from Deloitte and the Manufacturing Institute. And here's a statistic for you. It predicted that 2.1 million manufacturing jobs were going to go unfulfilled by 2030, and that skilling up is the gap. So then how is this going to affect people's lives and people's jobs? Well, Shankar, you and I have experienced firsthand a number of generational talent transitions in semiconductors where senior designers have left the workforce and the next generation of technology innovation is driven by that next generation who've ramped up, they've learned from the experience shared by those senior experts and leaders over the course of many years. It's the same situation in manufacturing. We've got a generation of talent right now who have 28, 30 years of experience, and they're going to be retiring over the course of the next several years. And it takes decades to build up the expertise, the tribal knowledge, if you will, of these operators, machinists, builders have. And the question is, how could we use artificial intelligence to preserve the expert tribal knowledge and experience of today and impact the future jobs and lives of the future generations of machinists, manufacturers, designers, accelerate their learning curve, bring them to an advanced skill level faster, so we can advance our capabilities, our processes in this area, but also help the next generation of talent reach that advanced skill level in a much shorter time period. And of course, the benefits. Tying this back to your question, how will this benefit the trainees? Well, they're with an AI augmented system, they're going to reach an advanced skill level not after 4 to 5 years of on the job training, but potentially after 6 months of functional training with an AI augmented system. It's very exciting. And of course, it also could free them up from automated repetitive tasks so they can focus on the higher level technical engagement of planning, control, and ultimately creating a safer workplace. So I think it's got a multifaceted benefit to people's lives and their livelihoods and in our workplaces today.
Margaret, I love your optimism about the future, and I am as well very optimistic about what the future holds. So, from what I'm hearing from you, along with the AI revolution, the information revolution, there is also an industrial revolution that's happening. So, a lot of the mundane tasks will get replaced by intelligent machines. Uh, what about there's a lot of concern among people that this could lead to mass unemployment. I'm not sure that's the truth, but where do you see a lot of the so-called low-end jobs, whether it's typing letters or administrative jobs, managerial jobs, and same in, as you said, in industrial applications, the basic repetitive tasks will go away. How fast do you think the high-level jobs will ramp up?
Shankar, we've always been concerned about this. You and I in the industry, looking across the scope of of our engagement in semiconductors. If you recall, and I'll just take a step back in time. You remember in semiconductor design, we used to design at the transistor level. So much of the drawing and design work was done manually. Well, today those processes are automated. The skills that we have in semiconductor to design today is, how to keep pace with the technology process using simulation, using automated design, using system level requirements to keep pace with the modern and future chip requirements, both for size, for performance, now for function. And that's a great example that jobs haven't been lost, but they've shifted. They've shifted the skill set, and you and I in the course of our careers have needed to keep pace and have enjoyed keeping pace with that trend. And as I refer back to this Deloitte study from 2021, there is a macro trend that's taking place right now. That's digital transformation. The pace of digital transformation in the manufacturing industry is likely to continue, and this is going to be a constant trend, redefining the work for the human operators and the humans involved. The skills needed in the smart factory of the future are going to be different from the skills used today. So, if we look at the trend of digital transformation, we look at the talent gap that we have in filling the manufacturing jobs we need. Um, I feel the danger of losing manufacturing jobs to AI is limited. Digital transformation well underway in the manufacturing industry, already creating a need for upskilling to keep pace with this technology development. Yes, as we apply AI to this sector, I do feel the requirements for the jobs are going to change. However, with AI augmenting human operators, making them more efficient, reaching an advanced skill level faster, creating safer, more efficient processes that will, accelerate our overall efficiency, and it can ultimately support our goals for sustainability. I think there's tremendous advantage and opportunity there. So it is limited. I absolutely agree with you.
That's great to hear. Where do you see things going, particularly for women? Um, there was a time when you started in the industry, there were very few women in our industry in semiconductors and electronics. How has it changed over the years? And how do you see it going forward? And again, do we have what it takes to get women trained and excited about these kinds of careers in manufacturing, for example?
Shankar, I see a very bright future. If we look at the realm of semiconductor design, if we look at the realm of manufacturing, the smart factory trends, we have a unique opportunity. It is well recognized. I'm happy to say that it is well recognized in the industry, uh, that the path forward is creating a more diverse and inclusive workforce to attract the workers of tomorrow to drive these exciting initiatives and these highly or let's say evolving advanced technology workplaces. And companies are recognizing that in parallel with skilling up the workforce, they need to include diversity and inclusion initiatives as well. And this was cited, Shankar, I was very excited to see this was cited in the 2021 Deloitte study. And a statistic for you, I believe it was 57% of the manufacturing responses in Deloitte's survey had reported that they were already using advanced technologies to redefine job tasks, like automating previously manual tasks. This is going to be an opportunity to recruit and drive an awareness and a wider potential uh, set of talent. These are exciting digital, highly technical applications that will hopefully appeal to a wider set of workers, including women globally. And
Thank you.
Shankar, it's an opportunity we can't lose. You just cited uh, companies like India. You mentioned Africa. What is the tangible output of these AI augmented systems in manufacturing and construction? We talked about building construction. Well, climate change is affecting everyone. It is a key priority. AI augmented systems have a potential to help us here, and we can't overlook the impact of our industrial and construction applications, impact it's having on the planet. Construction is one of the most critical economic sectors for addressing climate change. And Shankar, I was unaware of this. This is something that I've been looking into and I'm quite excited about. Let's look at construction. It accounts for over 39% of global CO2 emissions and energy consumption. And this is affecting everyone. This isn't just in industrial nations or certain countries or certain cities. This affects everyone. What happens in one area of the world can affect the climate in another area. So think about this, the production of construction materials. I was looking at this, Shankar's, it was astounding. The production of steel, of glass, cement is responsible for over 11% of total CO2 emissions worldwide. That means the CO2 emissions of cement production, if you were going to compare it, is 2.5 times higher than the emissions that are created by global road traffic. So Shankar, we have an opportunity here to make a global impact and improve people's lives and our planet by conserving these materials and energies with AI augmented systems in the manufacturing and construction industries. So taking it a leap further, what is the impact this could have on people's lives? We could effectively address our climate change and reach our sustainability goals, which of course affects everyone on the planet. Shankar, if I can reflect on an example of of this type of innovation wave. I can tell you about a project I was very excited about reading about. I recently read about uh, a robotic application that the Technical University of Aachen had developed. Now, Shankar, full disclosure, I'm from the Technical University of Berlin. Uh, different, different institution. But this is a robotic application that the TU Aachen has developed for the deconstruction of buildings. Okay, let me explain. Uh, when you're looking at the CO2 impact of building and construction, cement industry is responsible for about 8% of CO2 emissions. It's far more than the CO2 emissions from aviation, for example. As a matter of fact, the cement industry were a country, it would be the third largest emitter of carbon dioxide in the world after the US and China. So, okay, what's the opportunity here? Buildings that are demolished and that of course discarded, the building materials are discarded, they're ending up on the landfill, they're ending up as spilling in the roads and more, and it was a very large percentage, more than 70, 75%. So what are we trying to achieve? We could reduce the amount of CO2 emissions if we could reuse these building elements as secondary building products. And that's the focus of this robotic application from the Technical University of Aachen. Their objective is to robotically control, so again, augmented human operator, augmented deconstruction process for buildings to maximize the reusability of building materials, namely those cement and concrete portions, as existing um, as existing material for building new buildings. Think about that. We were just talking about the impact we could make globally, US, Europe, Africa, India. So this is this is a great example of an AI augmented application. You still have an operator. The robotic application is visualizing the scene for the operator remotely. It's planning the adaptive robotic path it's going to take based on information about the wall layout, the input from the human operator, and then it's cutting the components in a manner which is minimally invasive, so that you have these optimal resulting materials you can reuse for the building. And of course, the machine then cuts out the components and saves the material, which would otherwise end up in a landfill. And for me, this was such an exciting application because it's an example of how a human operator that that is augmented now with this AI, the system now executes on a process that, if this was just a human operator alone, would require considerable tribal knowledge and many years of experience. And now this robot is efficiently transferring the human operator's direction into the operation of deconstruction, and they're already using machine learning for their control process automation and addressing challenges with the kinematics and executing on precise movements with this trained robot. Shankar, think of the applications. Take it out of building construction and any type of operation. Um, in manufacturing today, drilling or refurbishing systems. And this is, if we think about that upcoming workforce today, that diverse and inclusive workforce wanting to make an impact on the society and on the planet, addressing climate change with these AI augmented systems that create more efficient processes. I can't think of a better application.
Wow. Wow. In fact, it's so interesting. I heard the term deconstruction only last week. I always thought of it as demolition, and all you have to do is use some kind of a dynamite and break things down. And I guess that's how it was 20, 30 years ago. I
Absolutely,
remember.
Shankar.
And now it's so much more systematic, sustainable. There's so much more to it. Uh, and I hope it happens in every industry, including silicon. When we break down computers, we don't want to just trash it. A lot of it can be used. It has precious metals, rare metals, so much more to do.
Shankar, I was thinking about this. I see applications. You and I are talking about well-defined mechanical control processes, which are certainly challenging at this point today. But Shankar, what about some applications in medicine? Maybe not never replacing a doctor, but what about automated functions, uh, suturing, for example? Could there potentially be a future automated type of augmented system where this is supporting the human insights and the human experience of that doctor operator? Exciting
Yeah,
to think about.
you said you attended a conference or meeting this last week. What's happening in making AI systems more human?
Oh, I heard very exciting presentation from a speaker from Stanford, and the Stanford AI research program. Very exciting applications about how we can make systems intelligent about our emotions, without gathering direct information, but watching our facial reaction, the motions of our head, our body, and determine our level of fatigue, our level of interest, our emotional reaction to something. And this is This is something, Shankar, this isn't science fiction. This is happening today. There's nothing new about algorithms. Algorithms, you and I both know, have been in place for controlling systems for some time. But what we're talking about is AI controlled algorithms, which are going to involve an element of human trust. Shankar, we were just talking about the medical industry. Let's take another industry as an example, in aerospace and defense. Um, Algorithms have been used to control fighter aircraft for a number of years. I recently heard that, and I believe I read this as a report from February, that in less than 3 years, DARPA had developed AI algorithms that they applied to control, I believe it was an F-16 in flight. Now they're taking it a step further to see what are the pilots' reaction to this AI control, because of course it's very critical that the pilots trust this AI control if they're going to be takeoff landing in a dogfight, what have you. And they're using the same elements, Shankar, as they're looking at the pilot's facial reactions, their response to that AI to see if that trust factor is being demonstrated. So this isn't science fiction. This is happening. It's Shankar. How can this talented workforce that we have in place today transfer that to meaningful applications like building and construction, like manufacturing, semiconductor designs, and then ultimately, hopefully, as you said, medical, and how can we improve our treatment of very critical areas like mental health. Shankar, I'm very excited about the opportunities, and of course, we're exploring. This is a new world for education, but we've just talked about the fact that roles are becoming more technically advanced. There's going to be a need to learn about the control software, to learn how to effectively implement the software, drive these AI augmented systems. We need to help the next generation ramp up and reach that skill level faster, and these AI systems would be a great enabler for scaling the future students in a way that you and I have never seen.
Uh, well, thanks again, Margaret. I mean, we could talk all day long. There's so much going on. I'm excited, even the possibility of a meeting and thinking about what's possible to do going forward. And it's an honor to have people like you inspiring the next generation of engineers, women, people from around the world. And may you continue to inspire people.
Shankar, it's an exciting, brilliant, talented industry that we work in. I'm astounded every day when I read the headlines and the great innovations that are happening. I'm excited about creating a strong ecosystem that will bring new technology to market and impact people's lives and the planet in a positive way. So thank you so much for this opportunity and look forward to working with you in the future.